Okay, so next, let me introduce, and I believe he is with us. We have several mics here, so I'm gonna, let me see. Retired mechanical engineer Mike Melia will present an approach to inertial propulsion and discuss a video that he's put together showing a proof of concept prototype. So as you'll see, a primary drive is delivering perpendicular rotation in his device, and in normal circumstances, any peripheral force should manifest itself within as part of this rotation. But contrary to this, the drive that he's going to demonstrate is creating a linear thrust at a 90-degree angle to the direction of rotation. So again, Mike Melia will be discussing this, and now I have to find out which of our mics he is. Sir, Mr. Melia? If he is here. He's joining us from the UK. And he may not be here. We'll give him another moment. Okay, so I think that our guest is not here. He's having communication issues. It could be one or the other. Guys, do you want to do open discussion then? Oh wait, there he is. He's having problems with his microphone. Okay. So he is here. Okay, I see him. There we go. There we go. Mike? Yeah, sir, you're still muted. Or actually, you were not muted. Your microphone is just off. You might try switching the microphone volume on. Is there a separate volume button for the mic? The other thing you may look at is on your computer, you may have a volume control for the microphone. That may be all the way down.
You could try telling him too, if you can hear me, have him disable the microphone in the software and then re-enable it, and that might reset it so that it comes on. I have that issue all the time.
Okay, okay. And Mike, I'm not sure if you heard Thomas, but he suggested disabling and then re-enabling the. Oh yeah, he said he'll try that. Yeah, and we do have a couple of other suggestions. Josh suggested turning the auto adjust volume off and adjusting it manually. You may be able to turn that up. And Billy suggested that it's possible that it's muted in the Zoom window. And it does look like in Zoom, it's muted right now. So it looks like you have mute on. That may have turned on automatically if you disabled the driver. Well, why don't we do this, Mike? While you work on this, why don't we go to open discussion if that's okay?
Which mic is this? Because I'm looking every Michael I've come across, their microphone is still showing the red
Yeah.
marker.
So I'm pretty sure. In fact, I'm going to rename him here. Mike Melia. There we go. Mike Melia. I'm just renaming him. Yep. I'm just renaming him now. It looks like it looks like his microphone is off, but it was on a few moments ago and it was also dead then. So why don't we go to open discussion, guys? And again, I apologize for the technical issues. And then for Mr. Melia, when you do have it there, no worries, we can pop back in. Or if you'd like, we can also postpone. And I could do a test session with you another time. We could get the mic set up.
I'll say in that open portion, it'd be nice if some of these people who are working with math to this degree could work on, the formulas for basically finding how much energy at what frequency of photon is necessary for bonding versus ablation on various materials. Because that would basically expedite manufacture capabilities so that we could try their theories out. Just, drop of the hat, next to no money, not having to, get a giant grant or anything else like that. So cheap, fast, and easy to manufacture technology is going to make this all go a whole lot faster. We'll be, 100 years from now, kids will be like, oh yeah, they thought this was hard while they're like in school learning about it.
Yeah. Well, and again, let me say
Tim, isn't there a call-in number that they can just call in with a cell phone for audio?
There is. Mike, would you like to try and do a call-in number? The quality probably won't be as high, but that would be an alternative. Let me paste that into chat just in case. And if yeah,
I was gonna say the only other option I can think is for him to completely shut his system off and reboot it and then rejoin the call. Because that might be something that, the computer's just having an issue with because it's been on for a while or something. So, or he was running something before he joined that is conflicting with like Zoom. Skype does that. It will take control of your mic and not let go of it to go to the Zoom call. I've had that issue too. So if you have anything else that's using your microphone, make sure all those programs are turned off and then do a disable and then re-enable so you can try to get Zoom to pick it up and then go into your Zoom settings then and force it to the microphone you're trying to use.
yeah.
So that should help.
Actually, it looks like they have two machines set up there. Oh, which one is this? Oh, that's Falcon Labs. Oh, I see. Okay, that's rebroadcasting. Well, yeah, I would say, guys, let's just do open discussion for now, if that's okay. Or if you'd like, Mark, would you like to do lab updates now? That's something else that we could do.
We're in the middle of working on some stuff. I'd rather show you in a little bit when it's all ready. Plus I have a meeting in half an hour, so
Yeah.
We're hoping to get time. Do you have that phone number he can call into? I'm trying to find it.
Actually, I just pasted it in there. I just pasted in the local access numbers. He's in the UK, so he needs to find it.
Or use Google Voice to call in, which can run into all of its own problems. That is really disturbing, by the way, Mark, seeing his face through your filter when he moves around. I just realized what that was, but your voice.
Actually, that's not what that is. What you're
What
you're looking at is a microscope that's looking through a fiberscope that's pointed back at my screen. So this is the fiberscope we're going to be using for the high energy experiments. And
we're not looking at a digital filter. We're looking at a literal real world filter of the.
You're looking at a digital analog filter or digital analog device. It's a whole bunch of fiber optic wires that are going through a tube. Basically to protect to keep the camera away from the experiment.
Yeah, flashback to the 1980s. Flashback to the 1980s. I remember that. Remember the fiber optics came out? That was one of those, back in the day.
Man.
Now we can look at Tim's face now. Tim, I don't see the phone number in the chat.
So again, I pasted in the page, the web page he would have to go to for local numbers, because he's in the UK, right? So he's gonna want, and here I'll paste that in directly as a chat to him. Oh, I did it as a direct message to him. That's why you're not seeing it. Sorry.
Oh, okay, no worries.
That's my fault. Yeah, and Mike, if you'd like, you could try rebooting and entering the call again. Do you want to try and reboot your machine and enter back in? Well, so Mark, to ask about this fiber scope, it looks like the visual quality on this is not as, it's not as high as I would have guessed. I guess so.
Well, here it is.
Do you anticipate any issues using it? I mean,
it kind of has its resolution and it's kind of limiting, but you're able to look at anything. You're able to stick this end inside of a microwave oven and still get a clear image out of it without frying your camera. And I couldn't think of any other way to do that. So here we got batteries, and there's a light at the end of it. So we're gonna be able to see inside the waveguide as the experiments are going on. I also got some temperature probes that we're working on. And this at the end over here is a microscope that I attached on to give us the visuals that you were seeing before.
now so you've got it looks like there's a metal probe end on that. Is that that'll have issues in the microwave too, right? Is there a way to isolate that?
I can remove the metal sheathing. It's not actually an integral part of it. It's just
Oh, it's just over the okay.
Just over
Well,
it.
if you make sure the metal's not grounded to your camera and you ground it to the frame of the microwave, it will just route everything that hits it right back into the microwave where it belongs anyway.
Exactly.
So
I was just
have
wondering
you
if
tried, I was gonna say, have you tried using Lexan with a sheet of glass over that? Like the glass on the other side of the
guys,
Lexan,
I'll be right back.
like that, you know. That way, if the glass breaks from something smacking it, the Lexan will still protect it, but the glass will protect the Lexan from being scratched.
I haven't gotten that far, but we may give that a shot. It's a pretty small tip over here, and
Right.
I'm gonna try
Yeah,
to
being
remove.
able to get into tight places, that would be excellent. You know, you basically got like.
It's not just about tight places. We do have a little USB camera that's at the end of, with the wires that go at the end of a sort of like a boroscope that you'd use, like a mechanic would use. Mm-hmm. But try putting that near any RF interference and the thing just goes haywire. This is just pure analog. All you're looking through is fiber optic, strings that are thinner than a human hair bundled together. And
put the camera far enough away that the RF is suffering from square inverse loss, so that it doesn't have enough energy to damage whatever camera you're using.
Right, and all you're getting is the optical.
Yeah, I'll have to build one of those. I like that idea.
No, you don't have to build them. They sell them on eBay. They're like used in the medical field, or they used to be used by mechanics, but there's much cheaper ways to do it today.
Right. Well, I've got access to single fibers though for fiber optic.
You need a bundle. You need I think this has 10,000 fiber bundled together in this tiny little bundle.
Right. So, well, and that's what I'm saying is take a bunch of that coiled up and then cut the ends flat, break the ends flat after wrapping it to make sure it's a single bundle. I just like that idea. Even if I don't use it for any experiments, I'm sure I can find something at least for, artistic use.
Todd's asking, do we know where that scope has been? I don't want you to do that. Well, I know where it's going to be.
just clean it with the strongest cleaners you've got. You can't get any cleaner than that. Because everything has been in a bad place if you go back far enough along the material timeline. You sure that water that you're drinking hasn't been inside the intestines of a dinosaur at one point?
Here's a close-up of the end. It's not really focusing very well. Also, when I turn on the light here, you can get an idea. There.
Okay, and let's see if
Nice.
it looks like Mike has logged off. Okay, so maybe he'll come back. But again, we can just do open discussion for a while. So Mark, you're still working on lab updates? You're still putting stuff together?
Yeah, actually, Tom is in the other room. We have a big update on the gyroscope project, and we also got some more sensors that are pretty much ready to go for this Alzafon experiment. I just have to take the waveguide apart now to install all the sensors, but proof of concept is there already. I got the cam figured out. We got to drill some holes in it to get temperature sensing and visual sensing inside the waveguide as the experiments are going on. So we'll get a lot more data, and we'll know what we're doing. Pretty much.
Yeah, there you go. Okay, and it looks like Mike is back, and he doesn't have video or audio enabled yet. There we go. Okay, it looks like his video is still off.
How about we go to Q&A for David Chester in the meantime, because there was lots of questions for him.
If David is open to it.
Yeah, that's fine. That's fine.
Oh, okay. I just didn't want to. It's so technically complex. It felt like an interrogation. That's the thing that scares me. You know.
Ah, that's fine.
Okay. Well, yeah, we can do that then. So yeah, I guess anybody.
He's a scientist. That's what peer review is interrogation. So that when he passes the interrogation, they go, okay, put that one on the board. That's legitimate. We're going to start following that.
I know, but it's so intense. That's the part that scares me, right? It's like, you know. So
I'll live.
Yeah, well, okay. So yeah, anybody with questions for David Chester then? And David, thank you again, sir. And oh, I should let me do the let me see. So option sorry, let me leave this out. Option Y on Mac or Alt Y on Windows, or the button in your Zoom menu, but Option Y on Mac or Alt Y on Windows for questions. And go ahead.
Are you free for a question, David?
Yeah,
I know I asked a long one before. Sorry about that, but it looks like we have another minute. What about stuff like entropic gravity and some of the stuff coming out of that, modified Newtonian dynamics? Just, do you have any thoughts on that, or are you kind of
Yeah,
anti,
I
you know, I mean,
I don't have anything against it necessarily. Yeah, as far as I understand, a lot of the modified Newtonian dynamics, it's difficult to make a theory that doesn't have too many parameters, as far as I can tell, for the most part. But that's just a very high level observation. I haven't studied too much extensively there in great detail, but yeah, I mean, a lot of that's trying to figure out how to get expanding universe type stuff worked out. Yeah, and then the entropic gravity stuff is certainly interesting. I mean, yeah, there's the Bekenstein stuff, and then yeah, so I mean, a lot of the Berlin gravity stuff. So yeah, I mean, that's good work. I mean, they have a description of just even Newtonian gravity. You can get this entropic formulation of it, so that's kind of interesting. You can do the same thing for general relativity, and then I guess Berlin has his own ideas on dark energy and dark gravity that are inspired by his views on entropic gravity, but it's not clear to me if like that's the only way to do it, just because, you know, he was the guy who pioneered some of the entropic gravity stuff. That's kind of the direction he went into, but I mean, it seems like there's a lot of stuff that could be done with that. So yeah, I mean, it depends on, some people have different perspectives on gravity, like should it be quantized? Like should it just be this emergent classical field? Some of the pure gravity people look at it that way. So yeah, there's a lot of different ways to potentially look at what gravity actually is. I personally prefer to trying to quantize gravity just to make it like the other forces, but that's just me.
Thank you, thank you. And also real quick, you're talking about in kind of gaugifying gravity, if I can say it that way. Does ADS CFT fit into that scheme?
Yeah, to some degree it seems, yeah, it looks like, I forget, I've been trying to figure that out. On one side, you have this bulk boundary correspondence. It seems that global symmetries on one place turn into gauge symmetries on the other. So it looks like gauging the conformal group on the boundary was mentioned by Andrew Strominger at one point. Yeah, because the isometry group of the anti-de Sitter space is the conformal group. So I don't know if that implies that there's the same conformal group gauged on the boundary. That's the current perspective that I think it seems people are looking to, but it seemed that Strominger was stuck about something that I didn't fully understand yet about that whole story. But yeah, I mean, you could study ADS, CFT. I mean, a lot of the ADS stuff, a lot of the supergravity stuff is secretly, well, they know they're doing gauge gravity, but then a lot of it is they'll have the torsion related to the gauge theories that I talked about, but they kind of try to ignore that fact. So, but it's there. So all the supergravity stuff really is limiting down to Einstein-Cartan theory, which is gauging the Lorentz group. Maybe they, depending on the formulation, they might write it in different ways, but yeah, that's all related to that.
Cool, man. Cool. Great answer. Thank you.
Now, David, with some of the comparative analysis stuff that you're talking about, is there a way to use like computer programs? Is there a way to use like algorithms to do comparisons on that? Or is it too tied to kind of like the experimental models and the concepts, I guess?
You could, it would just be a lot of work to set that up. I mean, I got close to figuring out how to get like metric affine tensors in Mathematica, but I just I didn't perfect the covariant derivative stuff. So yeah, I mean, there's definitely stuff you could do in principle, and there's some code that helps work with some of the tensors because it can get pretty complicated. So but yeah, I mean, I guess if you work hard enough, you could get a computer to do anything, right? But yeah, it would be challenging to set stuff up, and I don't know, I haven't seen anything too proprietary out there that would really be great. I mean, there's some of the tensor stuff, like I was saying, that is out there that you can get to help with the tensor calculus, but you'd have to do a lot more built on top of that to get into some comparison like that.
Yeah. I was just curious because I mean, it seems like that's kind of one of your focus areas, right? Is like the comparative, looking at this versus that versus the other model. And there was like, I was just thinking, if there was a way to automate some of that, and then you could see kind of what dumps out the other end,
Yeah, and I mean, because there's even varying layers that you can compare the theories. I mean, you get the equations of motion, but then those are just the classical equations. Then there's the quantum behavior. So yeah, it's pretty daunting to think about. Like, it's like, where am I going with this rabbit hole right now?
Yeah. Does it feel like there will be a big breakthrough, I guess?
Yeah, I mean, I mean, honestly, the amount of breakthroughs that are happening right now are pretty surprising. I mean, even just the fact that we're getting papers talking about like Alcubierre drives, like talking in these like mainstream theories and finding like, it's like, you don't need any exotic matter. To me, that's like pretty awesome. And then, I mean, just even this metric affine gravity stuff, like it's been around for about 50 years, but just in the past 2-3 years, there's been a lot more papers coming out towards it. And then even like, I've been skeptical of string theory forever, but I mean, I'm now more open-minded to it. And even there, like there's a lot of progress that's being made really in all directions right now. There's just so much going on. It's hard to keep up because there's just so many papers being published. There's so much work. And yeah, hopefully one day computers will really just help with organizing all the papers, like connecting, like what are all the buzzwords in all these papers? Like how do we, we can look through trees of who cited who, but I wish there was like a better tool to like really aggregate all the papers based on the topics like more clearly. That would be helpful for figuring out, because I mean, all the time people are discovering the same thing in different formulations, or or even in the same formulation, they're just not aware that someone else already wrote about it. So there's a lot
Yeah.
of work.
Okay, so let me see, Mike, I am looking at your screen share. Looks like you're on microphone 2. You might want to check your audio settings.
Click that drop down and make sure that there's not another microphone, and maybe that's one that basically isn't connected or something.
Oh, okay, it looks like there's only, there's only one
Yeah,
mic there. Okay. And so, Mike, you might try test your microphone. I don't see a button for it either. You might try clicking, maybe try clicking
Click the
them.
troubleshoot. Yeah, I think
Or-
that's where the button is supposed to be, and it's already seeing there's a problem. So drop down to over where it says troubleshoot and click it. Yeah, there you go. Sometimes it'll fix itself, but I don't trust any operating system to really save itself. 99% of the time, it just basically makes things worse.
So, back in 2015, I went Mac, and I have not regretted it at all. I mean, Macs cost more, right? But I still haven't regretted it at all. It was worth
Once
the
you go
money.
Mac, you don't go back.
Yeah, I did 25 years on Windows, and I went Mac, and the thing that changed for me, because I've met lots of people in that 25 years who had done that, what changed for me was the majority of software is web-based, and the important stuff that I use, you can either run like VMware, right? Or you can do it in a virtual Windows system, or all of my stuff now has native Mac, right? So I waited until I could reach that point, but Microsoft Office now is identical on both devices. So you can do pretty much anything you can do on a PC on a Mac. And, that being said, they're moving Mac over to the ARM architecture. So I don't know, that may change things the next couple of years.
Too bad
Sorry,
they're not going to
Tim.
move over to that supercomputer technology that's got like the multiple cores, that each core has like 32 gigabytes of RAM right there on the chip.
Yeah, that's
That's ARM too. That's ARM too. It's like a souped up cluster of ARM processors. So it's like having a Cray supercomputer.
Yeah, Thomas, and I think that's what you're talking about with the Apple Silicon. They have what was I was just reading about the other day. It's something like 8 to 12 cores. Yeah, and what makes it different is the RAM is right on the chip, right? It's highly integrated, and so you don't have the delays. So
Right.
even though
You can't change it though. That's the
Yeah.
bad thing, is there's no upgradability without it getting slower. If you add more RAM after that, it's got to go through another bus. The ones that I was looking at weren't 8 cores. We're looking at like there were 16 cores per cluster, and there were 4 clusters.
Okay, you're talking about
They're
something that's a
big.
lot. Yeah.
Yeah, they're just releasing them now for like the new NVIDIA Tesla GPUs that they're replacing, because they used to use those for silicon graphics and whatnot to build their superclusters instead of a big computer in a box and then another one and another one and another one. Instead, they just cluster a bunch of these video cards together and use them. So this is just going to burn that into the ground. They're not going to be worthless. They're going to be completely worthless compared to them now, because it'll do
Sorry.
a card.
So can I just cut in a moment?
Yeah, go for it, Randy.
Mike, sure. Mike, can you see my screen? Can you see my screen? Yeah. Have a look at this. If you go down to the bottom right-hand corner and what looks like a speaker icon, if you right-click on that and bring up sounds, you'll get this pop up. Go to recording, right-click on the microphone and see if you've disabled it. Yeah? Okay, I'll stop sharing now. Try that. So just to recap, go down to the bottom right corner, follow my mouse pointer, bottom right corner, right click on that, sounds, you should bring up this, go to the recording tab, then right click on it, see if it's disabled. Well, it'll show if it's disabled because it won't have the green tick next to it. Okay.
Thanks,
Well,
Greg.
also, if it's green, if he right clicks it and disables it and then re-enables it, anything that it was connected to, it'll disconnect. And then when it comes back on, because he has Zoom front and center, it'll reconnect and connect to Zoom instead of whatever it was.
Yeah. Well, guys, let me again apologize for the delay. And in a few minutes here, probably in about 20 minutes, I think Mark will be ready for a lab update and we can just do open discussion after that. So, but I am pleased as punch that, I mean, Bob did a knockout presentation and then David did an amazing presentation. So I'm pleased as punch today, you know, and then I know Mark has a ton of stuff he's working on.
I'll say hopefully by the time I can actually do any kind of discussion about the manufacturing I'm working on, I'll be able to basically at the end take addresses to start sending copies out to people.
So I had something, this is maybe a little tangential, but you guys might be interested in this. I've been doing as kind of a hobby, I got back into doing photography, just landscape photography. And so I have a Nikon, and what I found was in the past, I was not shooting in RAW mode. I was shooting in JPEG mode because those RAW files are just painfully large, right? And so my brother said, well, look, you got to switch it because, you know, it's high color. It's, you know, it's going to capture the darks a lot better. And that way, when you put them in Lightroom, even if it's too dark, you can basically boost them up to make it look good. And that's true. So I put it into RAW mode. But the other thing that I noticed was I had issues with blurring in a lot of my photos. And so when I started shooting in RAW mode in the Nikon, I was able to get some pretty good photos. In fact, if you guys want, I can run you through some of them while we're waiting here.
You know, if you could get that hooked up to a telescope and use it for get some deep space photos, man, to share.
Here, let me, while we're waiting, I'll
Mike has a headset. Does Mike have a headset? Because he could bypass the internal microphone if he had like a external microphone to plug in the jack.
Yeah. Mike, if you're listening, let me see. Okay, yeah, and he's working to enable and here, let me share screen really quick. There we go. Okay, Google Chrome. Yeah, so this is, if you guys can see this, this is my Facebook. These are not the highest quality, but what is this one? These are night shots. I don't know if you guys can see that okay or not. Oh, and you know what? It's going over Zoom, so the quality's not going to be there anyways. But
It still looks really good. So
yeah, this is RAW mode. Now, in the past, these would have been, I was throwing out probably 9 out of 10 photos.
said it's night mode. You mean it's in the sunset mode, like just after the sun's gone down?
Oh,
over the
sorry.
horizon?
No, well, actually, the camera was just in, it was set in auto mode, but it's, I have a Nikon Z. I bought it for conferences for work. And the reason was a lot of those conference halls are poorly lit. And so I wanted something that would work in really poor lighting. But you can see this is deep, deep sunset.
Yeah, that is a very sensitive optic that you're picking up on, that to get that much light and not have any kind of issues with it, especially with the water. You can tell with the water, it's not blurry because it's not taking forever to get an extended exposure. It still looks crystal, like the, you know, the waves look separate. They're not blurred together. That's
Yeah.
nice.
Yeah, I was really surprised. And for me, the difference was putting it into the Nikon RAW mode. And I'm sure Canon probably has the same thing, but yeah, and you know,
If you don't have a cheap one, I have one of the cheap ones. The only way to get to the RAW mode or to control the compression is there's a thing like check something or other that you can load onto the little SSD card you load your pictures on. and it will kind of like hack your camera temporarily until you pull that disk out and reboot your camera, and then it'll go back to normal.
Oh,
So,
okay.
the expensive ones, though, you can do what you're doing. I guess they're probably using similar technology that Sony's using, and I think Canon, unless you buy a really expensive one, you're not going to get that mirrorless technology that Sony has developed.
Oops,
So
where's the
that's what yours looks like it's using, because it's really.
Yeah, this one is mirrorless, and I spent the money on this a couple of years ago, and I haven't used it that much because I had the issues with blurring, and so and then I just
that's actually an old secret to get your camera to stop blurring. If you want a dark looking scene, you overexpose the scene, but then when you're done, you then pull down the like the brightness and the contrast to make it look darker, and it'll come out crystal clear without looking like a bright daytime shot. So if you don't have what the technology you have now, I mean, we're talking like old school, whenever you really couldn't deal with that in that way,
yeah, no, that it's and let me see, I had a couple others, and then it also, it seems like it handles motion a little bit better. Oh yeah, you can see this, my other project I've been cooking. Seems like it handles motion pretty well too. This was I got stuck at the railroad crossing, and I said, what the heck, I'll pull the camera out and see what I can get. And so this train was, I think it was probably only going about 20 miles an hour, but still I was standing right next to it when I got these. So
Can you do video with it too?
yeah, you can. I haven't used it for video.
I'm just wondering what the fastest frame rate you can set it to when you lower the resolution, since sometimes you can basically get those cameras to basically give you a slow motion effect. Meaning you can capture things that you normally wouldn't see because it's moving too fast for a picture or for normal video, but you can capture it because it's just going so fast, slowing it down for you afterwards.
I had some trouble with the water in these. The issue was, well, I don't know. There's a lot of different shades of white, I guess, or shades of light. And
those droplets look separate though.
Yeah,
I mean,
yeah,
you
no,
have to zoom in to really see for sure, but it does look like it's still got it pretty clean on that shot.
yeah, I didn't have issues with the what would you call it, the resolution. I had more issues with the color, and I think part of it was the green, right? It's like if I was able to get the green, I wasn't able to get the white, or vice versa,
Right, that's the same problem with like either everything is blown out on the moon and you can see the stars, or everything is pitch black in the sky and then you can clearly see the terrain of the moon. So
yeah,
you couldn't adjust for both. There was no way to take a picture of both at the same time. One was either too dim or the other one was too bright.
and you can see,
oh, they faked it. It's like
in the Seattle area, you can see that. I mean, it's the middle of winter, right? So I'm not getting any flowers this time of year. Yeah,
that's still a whole lot better than a lot of places in the dead of winter. Most places you'd have to adjust it down because everything would be white.
and
the water would be stop still. You could take a picture of it and it's not going to move for like a couple months.
I did get seagulls. That kind of surprised me. Right after sunset, I don't know, maybe they decided to feed or something. Right, there really weren't that many flying until the sun finally went down, and then they just started to,
You should try catching some evening shots of the bats near a city. The way they kind of, like the video, especially because of the way they kind of move like black smoke through the air.
Yeah, you know where they have bats? Down in Austin. When I went to visit there, they got this big bridge down there, and they got just tons and tons and tons of bats.
Yeah.
And then
that seems to be an issue. That Tulsa has that issue too. They have a bunch of subterranean areas that the creeks and waterways had to be completely encapsulated, and the openings that lead out of those tunnels will just be covered in little brown bodies during the day from them sleeping in there.
Oh yeah, yeah. So yeah, that's been my project for the last little while. So when summer rolls around, in fact, you know what? I'll put my Facebook up here. Oops, sorry.
It's time for you to go up to Falcon Labs and do some video work for them then.
Yeah, actually, we were talking about that. Yeah, and let me see. I guess we're still kind of an open discussion, guys.
I think this is something we probably need to work on within this group of people that are gathering on the same pretext, is to network people together for, like, assistance with computer hardware and stuff like that locally to where they're at. Even if they're not directly interested in this, if you know that they're into computer equipment and they're a friend of yours that's living, say, where he's at, that could help him out with that, I think that would go, miles toward solving a lot of, like, the problems once we have better communication, because they have better tools and whatnot, or have, better working tools due to the help they're getting.
Okay, so let me see. Harold has had his hand up patiently, sir. And it's open discussion, Harold. You don't actually have to put your hand up.
Yes, I wanted to ask a question about David Chester. He spoke earlier about gravitomagnetism. And what interested me is, since there have been so many studies, and I know there are a lot of papers on studying planetary gravitomagnetism, etc. If anybody has theorized that there might be a particle related to gravitomagnetism in the same as gravity has a graviton, a particle. Has anyone made that up? I mean, investigated that? Any theory, any papers on that?
Yeah, so I guess you would say it's basically a piece of the graviton, in the sense that an electromagnetic wave is like photons. I mean, everything's just fields. So you can talk about electromagnetic wave, you can talk about light, you can talk about photons, but they're all just kind of different facets of the same thing. So when you look at it from that perspective, you could argue that gravitons are related to the gravitomagnetic effects that most people are talking about. There is also a Calb-Ramond axion. There's gravitational axions, and one might argue that that is a different type of gravitomagnetic type of effect, and it seems that's related to torsion. So if you had propagating curvature, that's like a graviton. If you had propagating torsion, that would be a different type of gravitomagnetism, but not the one that most people are talking about. But yeah, I think the one, I mean, anything coming out of general relativity, you can get that from a graviton.
But Heaviside, when he wrote the theory, when he theorized gravitomagnetism, he did not say, they said particle. I guess back then there was no idea about particle relationship, but the graviton have been made. But it seems to me like, since the gravitomagnetism is related to magnetism, and graviton is just plain gravity. What I'm questioning is there a distinction? Is there a separation in there? Because it seems to be graviton, no relation to magnetism, but gravitomagnetism does not have a particle, and that is the mainly curiosity. What is your thoughts on that?
Yeah, so I guess when someone says gravitomagnetism, it doesn't really have to do with magnetism. It's an analog from electromagnetism, the analog of how magnetism works in electromagnetism to how something similar works in a theory of gravity. And so just as like a photon contains like an electric field and a magnetic field, you could look at the polarization structure of a graviton and maybe break it into a gravito-electric and gravito-magnetic component. But yeah, those are just words. So yeah, they really are separate. Like when you say gravitomagnetism, I mean, it's just all gravity. It's just a focusing on an aspect of the gravity that might relate to something rotational in mind. Yeah, so I think that's probably something a lot of people can get confused about when you're like reading all these theories all over the place. When you see the same words used in different theories, it can kind of be a challenge to disentangle them. And I would also just point out that there is the Heaviside gravity theory. That theory is contained in some of the supergravity theories, but it's not like they're associating all of gravity to that. They'll add it as a separate particle. So there was this one paper by Joel Shirk around 1974 where he had a paper talking about an anti-graviton that was associated to something that it looked basically the same as the theory in Heaviside's gravity, but that was adding it to general relativity. So they had this like theory with gravitons and anti-gravitons. And once again, you could go through the same story and say, well, that anti-graviton had like a gravito-electric and a gravito-magnetic thing, but that it's the same math, as Heaviside, but it's a different theory now because now we're adding that to the ordinary graviton and associating most of gravity to that graviton. So yeah, it gets a little complicated to sort out how all the math and all the words relate to each other, but hopefully that helped clarify a bit.
Yeah, it does a little bit. Thank you very much for the explanation.
No problem.
Great show too. Great presentation.
Thank
Get
you.
a lot of detail, a lot of good information. It was great. Thank you.
Appreciate it.
Do I take a question, Tim and David? Could I take a question?
Go for it.
Yes?
Yeah.
Okay, I'll just turn on the web camera.
Oh yeah, thanks, Ronnie.
Yeah, I'll just start video. One
Yeah,
second.
I think we're pretty mellow today. And I'm not even sure what I'm gonna do when we edit here.
You're mellow, are you? I'm not
Yeah,
mellow.
I think we're mellow. We're mellow. We're mellow.
I was distracted by the news. Sorry, David, I missed your presentation. I came in at the end, but I will catch it online. I was distracted by the news about the NATO Ukraine thing, and apparently Russia are now tit for tat up in the ante. They're talking about putting missiles in Cuba and Venezuela, and that kind of upset me. But anyway, to get back to what you were saying, so if I've got the camera at the right angle here. If I understand field theories correctly, they're all a little bit of it's a bit like when you study simple harmonic motion, as a kid, and they say, oh, the sign you approximate as X, you make it linear.
Right.
And isn't that always the case with these field theories, that they're only the linear case, right? Happens to be so, works fine for QED. So highly linear theory, yes, apart from that very high field strengths. But gravity is inherently non-linear. And also, as you probably went through your talk, because I saw from the comments, you've got this infinity of infinities, yes, from when you try to quantize it. What do you think a proper quantum theory of gravity will look like that includes non-linearities? I mean, are we talking a bit like when you have non-linearities with light in materials, how you can say have photon conversion, you get spontaneous conversion. So you won't necessarily have one graviton, you'll have a sort of non-linear effect where it splits in two. And that's basically my question, because how would they, and string theory is based on that as well as string theory, not a lot of people know, is a linear theory. So I'll hand over to you now, David.
Sure. Yeah, that's a good question. So when you say something is linear versus non-linear, it depends on the context somewhat. So I think there's two main things to focus on. First, let's just take classical field theory. You have the field equations for those classical fields. And you're right that Maxwell's equations is linear and general relativity is nonlinear. And so that's one notion. And then, so you could take a linear theory or a nonlinear theory at the classical level, and then you can quantize it. And so The quantization of quantum field theory, this is related to harmonic oscillators. Exactly as you were describing, you get a linear potential that leads, or let's see, yeah, it's a linear force there. You have a quadratic potential and a linear force for a spring, just an ideal spring, a mass on a spring. And all of quantum field theory is kind of based on this idea of simple harmonic oscillators all connected up. And because it was realized that you can have the quantum harmonic oscillator gives you like different energy levels where you can associate a particle with a different energy level, and the energy levels have the same gap between it. So you could say I have 1 particle, 2 particles, 3 particles. So there's a quantization of the field in that sense. And so you get that you get these, these quanta, these particles in that sense. So obviously there are issues perhaps with quantizing gravity that everyone talks about.
Okay.
But let's see, with quantum electrodynamics, there's still problems when we don't actually know how to compute quantum electrodynamics exactly or non-perturbatively. And it
Correct.
turns
Yes.
out that adding this is a paper by Poplasky that came out a couple of years ago where he actually added space-time torsion to electrodynamics and found that he got a finite bare charge. So it removed the infinity problems. It's more philosophical problems with quantum electrodynamics. Like we can do the calculations in QED, but it seemed like it required an infinite amount of energy just to create a single electron because it had an infinite self-energy. But it turns out if you add gravitational torsion specifically to QED, you get a finite self-energy. And so no one has tried this with gravity yet because it's so difficult. This result came out 2 years ago, but to me, that's encouraging because if we apply torsion to gravitational theories, that might help clean up some of the infinity problems in gravity. So that's been a conjecture of mine for a decade. I just haven't found the time to actually do the calculation because that would take about a year to do.
Not just fair as well, because they reckon that a theory of quantum gravity will solve a host of other problems like wave function collapse. Some are looking for nonlinear Schrodinger equations and so forth. Yeah.
So you could just to wrap it up, there's one final thing you could do is to consider nonlinear springs. So you could invent some new quantization procedure that is using, instead of ideal springs for our quantization of these fields, you could imagine some nonlinear spring, and you could try to construct some quantization procedure from that. And people have looked into this and initially tried to argue that those theories are problematic, but it turns out, and this relates to non-locality, it seems, in some instances, and people are starting to slowly get better at realizing that maybe there's some way where you can get some of those theories to work out nicely. So that'll probably take a few decades to really nail. So there's different notions of linearity and nonlinearity. First at the classical field equations, and then when you quantize your theory, let's say you're building off these simple harmonic oscillators that are linear springs. And so in one sense, there's not necessarily a problem with applying the quantization to a nonlinear theory. If the theory had nonlinear field equations like GR, you can quantize it. I mean, GR is finite. You can do graviton scattering at the first order correction and get a finite result. And actually, they just figured out how to get the second order correction for 2 loops in just pure GR as well in the past, that was like 2018, so like 4 years ago. So yeah, I mean, you can make sense of quantizing nonlinear theories, and then you could also imagine some nonlinear quantization procedure that would be very, very sophisticated.
Yeah, it's a tricky one. I mean, the maths is horrendous. It might not even be humanly possible without the assistance of computers, a bit like computer-aided design. Yeah.
And guys, if I could jump in really quick, Mike just IM'd me. He said they've tried everything they can. They can't get the mic working. So we will get him rescheduled. And then Mark Sokol, actually, he's on another call. So we can just continue with open discussion as long as you guys would like. You don't have to raise your hand. you know, David, if you'd like to answer more questions, that's totally fine, but.
Yeah, I'll stick around.
Okay, yeah, and other than that, I think we're just mellow. Again, guys, let me apologize for the technical issues.
Jumping in at random, guys, back on Bob Greenyer, the first speaker's talk. It looks like transmutation is kind of in our interest set here, even if some of us take a real hardline view as far as it being very likely. But you could maybe kind of spitball Einstein-Rosen bridges to facilitate transmutation of the elements, taking flows of like protons in acid compounds and transferring them directly into the nucleus to upgrade elements or stuff like this as an application of gravity theory.
Yeah, but Bob has so much material. So the interview that he was referencing, that was Stanislav Adamenko from Proton 21. That was an interview that I did back in 2006. And I mean, Bob took it so far beyond what my interview was. One of the things that I remember from that, and maybe this was the electron eating. So they were using a what was it, like an ion probe, right? And one of the things that he mentioned was they created what he called a black spot, and that was all they described it as. And they said they just kept pumping ions into it, and whatever they dumped into it, it ate. And so I think that was what he mentioned that in the slide. When I get the replay up for this, you can go back and look at his slideshow. But that was one of the takeaways for me was, they almost described it. I guess it's probably a bad term, but almost like a mini black hole, right? Like whatever they threw at it from the probe just went right in and disappeared, and they had no idea what it was. So they were never able to resolve it because the ions are what they use to visualize it. And they were able to visualize around it, and it was just this black spot. And he was like, well, I don't know, but we just kept pumping energy into it and it just disappeared. So.
Yeah, he had a lot of interesting things. I'll have to look more into a lot of stuff he was talking about.
Yeah, he's got a lot. I mean, Ken Shoulders had tons and tons of stuff, and then Ken was really good friends with Jack, so Ken and Jack corresponded all the time.
Yeah, I keep hearing that name, Ken Shoulders. I haven't looked into it. So what did he do? What's like the main?
Ken was he was the EBO guy. He was the exotic. Yeah, he was the one who started that, and he worked on that for years. And then he like him and Jack were, well, Jack's list, right? So, I mean, they corresponded on Jack's list for years. I used to get CC'd on those all the time, back and forth, back and forth. And then Ken Shoulders was also really good friends with John Hutchison. They used to correspond all the time on those lists. And then when Ken passed away, I guess Bob kind of took over his work, but Bob has extended things so much. I mean, it's in a way, it's almost unrecognizable, I guess.
Okay, yeah.
I want to say that's one of those things you mentioned this guy Ken that reminded me. If you guys can, like David, if you can get a hold of Ken LeBrun, he apparently like reworked a bunch of the math for radar technology because he didn't like the idea that there were fudge numbers. You had to basically take tests and then, use those tests, the results to plug in a number, and you didn't know what number you were going to get until you did the test. And he was able to basically work something out so that when you changed frequency or whatnot, you could use the formula, know what it was going to do, and it represented what was happening in practicality. So, I mean, like, I don't think he has the, I guess the schooling to build his own theories, but he seems like he's pretty good at basically taking a theory that you can't quite figure out how to get rid of that fudge number and figure out how to do that, as long as you can get some tests to give him a chance to take a whack at it. Like he was basically, taking care of all of the radar technology for someone that he won't be allowed now to talk about, any of that stuff for fear of going to prison, so.
You say LeBrun, Lebrun, or?
Yeah. He, if you want to look for, you know, his history on that, like finding him on LinkedIn, just look for revolution-green.com. Because as far as I know, he still holds that address, but he hasn't been able to basically maintain the site on it. It was just, you know, an alternative energy site, but he, you know, he started that up because of all the nonsense that was going on with Pez Wiki and a couple other sites like that, with the people who were running it having some really bad stuff about them coming to the surface and finding out that they were running a bunch of scams and whatnot. So, you know, they tried to start something to bust free of that and have their own forum where there were no scams and nonsense involved in it, just raw facts. So they were basically doing what Jeremiah Pop is doing now, finding, you know, zeros by testing things out to find out for sure, and then giving an honest result answer on that, you know, what they were testing, instead of having to, you know, just go by somebody who developed something that wanted to basically make it, you know, make it valuable, whether it was or not. So they were, you know, giving bad results sometimes. So he worked with Mark Darth Danzy for quite a while. That's the guy that got him to actually go ahead and set the site up. In fact, if you know about him, that's that's what they call him in the alternative energy community, because he shows up with test equipment and whatnot, and suddenly nobody wants to talk, or when he tests things, they end up finding that, you know, oh, there's, what's this wire here that nearly shocked me to death that you guys had hidden under here, you know. He'd basically just expose scams like crazy, but he wasn't trying to expose scams. He wanted to find an answer. He wanted a real answer, and he always showed up hoping this would be the one, but it was never, you know. So
Yeah.
he ended up getting that you know, black mark on his name of Darth the Danzy. You know, he's gonna come in, you know, like the Sith and cut you down.